All right, how's everyone doing today? Hi, everybody. All right. So, this is about our 6th lecture in the course out of, I don't know, how many we have, like 30 or something like that. And this is right around the time where despair sets in, okay? I've had several students email me expressing concern and fear, all right? Now, often I do things in this class by a show of hands. I'm not going to ask you to raise your hand if you are a little bit intimidated by the course so far, or if you're a little bit confused, because I know if I ask you to raise your hand and find out who is intimidated or confused, and you raise your hands, your fellow classmates will turn on you and devour you. All right? Isn't that what happens? No? If you are a little bit confused, don't worry, it's normal. If you're a little bit afraid, don't worry, it's normal. I'm doing a lot of stuff up here, and I'm doing my best to keep it simple, but it's a complex topic. And a lot of your understanding is going to come from doing it, okay? When you actually sit down and start writing project 1 on the computer and doing the coding, it will become it will make a lot more sense, right? There's a difference between watching me do it and doing it yourself. You tend to learn more by doing it yourself, right? Okay. So don't be afraid, hang in there. Just remember, we have some basic stuff we're sticking with, and I'm going to go over it again. A few announcements. I have been recording these classes. I don't know if you've noticed. I've been recording the classes, and they are now starting to appear online. I've linked them through the Blackboard page, and they're also on YouTube, because YouTube turns out to be the easiest place I can put hour-long high-def videos, because Georgetown doesn't have a good place to put those. And so they're being linked into Blackboard. You can always go back and look at portions of the class again if you need to. And in fact, I think that is often very helpful. As I get better with this video equipment, I'll be able to add indexes for particular topics. I haven't figured that out quite yet. All right? But if you go back and look through, so if you're taking notes right now and they are not as full as you might like, then that's not necessarily a problem, okay? Because you can go back. This isn't like I'm going to spew it out once and it's gone forever. All right. By now, you should have started working on your algorithm for project 1, right? What's the rule in this class for projects? Is it early still? A little bit, right? Better than Wednesday. Wednesday will not be early. Wednesday will be late. So you should be starting on your project. If you've started and you have questions, now would be an ideal time to ask them, because I would answer them. Yes, sir? Yep. No. So there's a lot of constants and variables to declare for this project. I don't want you to have to sit in your algorithm and list all of them, okay? What you can do is, if you want to indicate in your algorithm what you're doing, you could put something like a little comment that says age range 1 goes from 20 to 24. I don't remember if that's the correct age range. And then underneath, you can just use, age range 1 base, age range 1 max, whatever you want to name it, without having to go through and explicitly declare each one. So do you need to assign constants for the point values? Yes. Just think of a naming scheme for it. You're going to have to come up with a naming scheme anyway. And I'll be honest, the TAs shouldn't have any problem grading this, because, they've been programming for a while and they're used to the concept of giving things names based on a problem. So as long as you're not naming your constants, fluffy carrot rutabaga moss 1 or something like that that has no relation to the problem, they should be able to see what you're doing. Yes, ma'am. No, make it a constant. Yeah. It's less hard than you think if you think about how to do it. So for a couple of reasons, but yes. Yes, sir. Yep. That's true. Did you read the project specifications? Read the project page. It mentions whether the people are being treated or not. It's a coherent group of people that falls in one of those two categories, so we do not have to ask about it. And you know what really happened? I'll just tell you. I was out implementing this thing, and it was getting so long, and after a while, I'm like, oh my God, I had male and female, and it was getting so big, I was like, that would break their will to live if I made them do the whole thing, so I just cut it back and reduced the number of categories. So, yes, ma'am. No. Next question. I mean, you can use what you know if you want, but the grading is set up in such a way that you're expected to use what you've been practicing in class, not what you already know. So if you do that, you're going to confuse the TAs. And then they'll come to me and they'll go, this person used arrays, and you know what I'll say? I told them not to in class. Yes, ma'am. Yes, you can use switches within switches, and we'll talk about switch cases today. Yes. You can use ifs within switches. You can use anything inside anything, right? If you think about the computer, it's just a dumb thing that does one thing after another. And any one, right, it does like one operation after the other. Computers are, and they're stupid very fast. And so we can put these operations inside each other to build more complex operations, and I will show you that today. Yes, sir. Yep. In your algorithm you could, yeah. But when you write the C++ program, you can't just tell the, as long as it's clear what you're doing. And I'll just give you a hint right now, which I'll repeat next week. When you're actually coding this up, cut and paste is your friend, right? It's easy to cut and paste and search and replace and like rename the variables and get them similar. So I used a lot of that. Yes, sir. The user might input a value that's out of the range. They might, yeah. People range from imperfect to suck. So, yes, sir. We'll do that today. Yes, sir. Yep. Why not? What if they change? Yep. There's a lot of constants in this. That's the downside of this project. Well, you have a top of range and a bottom of range, and that's constant, right? Yes?
Can you use inequalities in C++?
Yes, and we will do more Boolean operators today. We haven't done the full expression. I've only shown you the ones that we came across while doing our sample project. So yes?
I know for the age range it should be declared as a constant, but is that the same for like the systolic range? Like
Yep.
59,
Uh-huh.
all those things?
Yep.
So we just don't have to write a whole list at the top declaring those constants, but should we use the names?
Yes. You should use the names in your algorithm as if you had declared them all. It's just I'm trying to save you the boring part of writing out 50 constants. You should not have any literal numbers. You can have numbers as part of your constant name or variable name. But you don't want to just be like, if it's less than 6 or if it's more than 10 or something like that. Yes. Pretend as if you had a whole list of constants according to some naming scheme that you dreamed up. Make sure the list of constant names that you come up with indicates what it should represent. So you could say, if we want to talk about age range, we could have age range 1 base, age range 1 top, something like that, and those would have constants assigned to them. Does that make sense? Don't call age range 1 base pink fluffy banana, right? Because that doesn't indicate what it means. So as long as you're consistent, the TA should be able to understand it and see what you're doing. Okay. Other questions? No? Feeling good? Bad? Just silent? Silence, good. Are you feeling despair? No. All right. All right, so let's review what we've done and we've talked about over the past few things. What is an algorithm? That does what? Ordered series of steps used to perform some task. Why do we talk about algorithms? Because we are learning to program, and programming is just a representation of an algorithm in a form that a computer can execute and humans can understand. Is this getting repetitive? That's fine. I don't mind it being repetitive because it's important. So here are some things that we've talked about. We've talked about developing algorithms, which is something that you are doing right now for the project. The point of developing an algorithm is to figure out what input you're going to take, what output you're going to produce, and how to put those two things together, right? You get some input, you're expecting some output. What series of steps does the computer have to do to turn your input into the correct output? Okay. So that's what we've been working on, and we did a little bit of that last class. We talked about comments. What are comments for? Yeah. For people who are going to read your code, particularly TAs and professors and graders, right? But other programmers. We talked about variables and constants. What's the difference between variables and constants?
A variable can have different values throughout the program, and
Mhm.
a constant doesn't change.
Exactly. A variable can have different values throughout the life of a program, and a constant, once it's set, never changes. We talked about how to do basic output. What do we use for output? Cout. We talked about basic input. What do we do for input? We talked about Boolean expressions. What is a Boolean expression? Yes, sir. Yep, some sort of expression that just tells you whether things are true or false. And give us one example of something we did as a Boolean expression. We'll open up the floor. Anybody? Boolean expression? Yes, sir. Equal, equal, right? Remember the equal, equal sign? That was a Boolean operator. It returned a Boolean. What does a single equal sign do? It assigns values, right? Single equal and double equals are different, and different in a very important way. We talked about if, then, else statements, which use these Boolean expressions and Boolean operators. If the expression is true, then do something. If it's not, otherwise, else, do the other thing. The else is optional. Not every then will have an else. We talked about integer versus floating point division. What is the difference between the two? I'm just going to start picking on people who look quiet now. Uh-huh. Yeah, so an integer division will return an integer number, and you can figure out the remainder if you use mod, what it would have been. And floating point returns a decimal. And how does the computer figure out which to do, given two numbers that it's dividing? Yes, ma'am. Exactly. If they're both integers, it will always do integer division. If either one is a floating point, it will always do floating point. And we talked about how to turn an integer into a floating point temporarily. How do we do that? Static cast. That's the C++ way, and I will show you the C way at some point. All right, so that's pretty much everything we've talked about. Let's go back and look at the program we developed as we were doing this. So here we are. Here's our program. We divide two integers, and we do some output with them. I'll make the font a little bigger. How's that? So, should we run it and see what happens, just for fun? All right, I made a copy of this, and I'm calling it divide2.cc, and the reason is I haven't got around to it yet, but I'm going to post the old one on Blackboard, so you'll have the old version and then the new version we did today, and you can go back and look. So you can see. So I called this one divide2. I didn't really change anything, so it should compile. And we say divide. Do we want to do integer or floating point division? Integer. And what two numbers do we want to divide? Great. And it's 3, remainder 1. Okay. Just ring any bells? Great. Let's run this program again. And now we're going to do x. And we say 22 divided by 7. And it says you're stupid. Please follow the instructions because x isn't one of the possible choices. Now, did we like this or did we not like this? Why did we not like it? Exactly. So we made a mistake up here, but the computer still had us doing input even though our program was doomed, right? Once we inputted x, it was all over. There was no way we're going to be able to divide two numbers not knowing whether it's integer division, but we asked the user for numbers anyway. How could we fix this? Sure, well, we can change our algorithm. And right now our algorithm is such that it says ask for what they want to do, ask for the input, and then check, right? The program's an expression of that algorithm, so implicitly our algorithm does this. It says, hey, choose something right here. Then it says, okay, now choose the input and divisor separated by a space. And now check and see if the choice is something that we like. So what we might choose to do is to rewrite our program in such a way that we check earlier on the user input and give them immediate feedback instead of waiting a long time. Okay. Does that make sense? Who's with me? Who's against me? Okay. So let's go ahead and do that. So here we are. We've made our choice. And what we need to do now is what? Check and see if there was a valid choice. Okay. Does that make sense? So how do we check and see if something is a valid choice? What language construct do we use to check and decide something? Yes? An if statement, absolutely. I mean, that's pretty much all we've got, right? So if, and then do some math. So let's check. We want to say if, and we're going to have some Boolean expression in here that we'll get to later. And if it's wrong, what we want to say is see out what they did wrong. So here's the algorithm we're developing. We're going to say if we have some undefined circumstance, which we are going to define shortly. If this undefined circumstance happens, we realize the input is bad, and we say, hey, the input must be an I or a D. And then what do we want to do after that? Pardon? We could re-ask. We'll get to that later in the semester. Okay, it's a perfectly valid thing to do, and it makes more sense. But for right now, we're just going to say, throw up our hands and give up, which means we're going to stop the algorithm. And how do we stop? Return 0. Okay, so here we are. Now we're going to check, and now we added to our algorithm this check up front to see if things were going to work or not. Right? Okay, so how do we check to see if the input was an I or a D? Only people raising their hands who all programmed before. You programmed before? Okay. Somebody who hasn't programmed before, hazard a guess. Let me remind you what we did down here. Right down here, we said if I is equal to choice or big I is equal to choice. And this is how we tested to see if these things are equal. So can we do something like that up above? Okay, what can we do? Yes, probably. How about yes, absolutely? So what do we want to check? So our conditions here are right? We're going to check and see if the thing that's input is not a capital I or little I, uppercase D, or lowercase d. Yes, we can. In fact, we can. Let's try not equal. Okay, so last time I told you about some Boolean operators. I told you about equal equal. I told you about and. I told you about or. There is also a not equal sign. So what we can say is something like if choice is not equal, and this is how you do not equal. Instead of double equal, it's exclamation mark equal. In Computer Geek talk, when we're talking through this, as I read the board, exclamation mark is way too long to say. So computer geeks often refer to the exclamation mark as a bang. So I will sometimes in this class say bang equal. Okay? Because computer geeks are lazy, we do as little work as possible for the maximal effort. Exclamation point is way too long to say as compared to just bang. Bang equal. Not equal. Okay, so you're doing very well. Why don't you coax me along here? Not equal to what? Okay. Great. So now we have this thing that says if choice is not equal to big I, then can we stop right away? Why not? What else do we have to check? Okay. And what we have to say is or. Now here it gets tricky. I always mix these up, right? Do we want an and or? I'll just go ahead and put the test in there. Okay. So let's think about it. If choice is not equal to I, and do we want an and or? How many of y'all think and? How many of y'all think or? Okay, let's give it a shot and see what happens here. We'll put in or because that had the most number of votes. We say if choice is not equal to I or choice is not equal to little I, input must be an I or D, and we stop. Okay? Should we run this and check it and see how we're doing? How many of y'all want to run it? This is what you should be doing with your own code, periodically just doing a little tech test. So I'm going to clear the screen. I will go back and recompile. G++ divide 2.cc.o divide. We did not introduce any errors, which is always nice. All right, integer or floating point. What do we want to enter here? We'll put an I in. Input must be an I or D, but I did enter an I. Why did that happen? Because it has to be and as the answer, but let's think about what happened. So here, up here, we put a little I into the choice, right? The computer is what? Stupid, and it just grinds along and it goes, okay, if choice does not equal uppercase I, does choice not equal to uppercase I? It is true that it is not equal to uppercase I, and it goes, oh, and here's an or, and if you have an or, if one thing or the other is true, then the whole thing is true. Does that make sense? If one thing is true or the other thing is true, the whole thing is true. That's how or works. So in this case, this one was false because choice was lowercase I and it said not equal to lowercase I, which was false. But this one over here said it was true, right? Because uppercase I and lowercase I are not equal. And so it said, I am a dumb computer. I'm going very fast. This thing is true. This whole thing's an or. I know if one thing's in the true, in the or, I'm done. So I'm done. How many of y'all follow that logic? A few of you. Okay, let's go over it one more time. And here we're just going to step mechanically, step by step, like we are a very stupid computer that is billions of times slower. Hundreds of billions of times slower, probably. So we input up here. We output, choose and enter a floating point division, right? We all saw that come up on the screen? Yes? We input into choice, and what value did we input? Upper or lowercase I? We put a lowercase I. So this right now, this choice refers to a box in memory, and what's in that box? A lowercase I. Everybody good so far? Great. Now the computer comes along, comment. Does the computer care about comments? Nope. Skip that. Comment, skip that. And we go, aha, if. Okay. So it looks and goes, okay, I need to know whether this entire statement inside these outer parentheses right here is true or false. Because that is going to determine whether I do the if or whether I skip it. Everybody got that part? Okay, so it says, how do I figure out if thing is true or false? Well, it says, okay, I know that one of the things I have to check is to say if choice is not equal to I. Capital I. So it goes, okay, choice. There's a box over in memory with that name on it. I will retrieve the value that's in there, which is lowercase I. And it says, is lowercase I not equal to uppercase I? And the answer is yes. Lowercase I is not equal to uppercase I. So this part is true. Okay. Now over here it goes, okay, choice is lowercase I. Is lowercase I not equal to lowercase I? That's false, right? And it says, okay, I have true or false. And what do we know about or? If one thing in there is true, the whole thing is true. If one thing is true or the other thing is true, the whole thing is true. So this whole thing becomes true. And then it goes, aha, I will just say see out, I will stop, and I am done. So, did the computer do something wrong? Did we do something wrong? What is it that we did wrong? We should have had an and in there. Because only if all of these things are true does it. So let's try again. We compile our program. Yes. We run the program. We say lowercase I. Is that what we want to say? And it goes, great. Give me some numbers to divide. And it goes ahead and it divides them perfectly. Are we happy so far? All right, let's try this. Try again. And now we say D because we want to do decimal. And it says input must be an I or D. What went wrong? We didn't add anything to our Boolean expression to handle the case where it was a D, right? Computer's grinding along very, very quickly. It says, okay, it's not an I. So what do we have to add here in order to check to see if it's the letter D? Another and statement. Yep. And then what? Now, what I've done here, just to keep all the code fitting nicely on the screen, I'm short one parentheses, you're correct. What I've done here, in order to keep all the code fitting neatly on the screen, is I have just kind of split the line. The computer does not care about that, right? The computer does not care about that. You could have one line that just kept on going and 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 going. And it would be very annoying for people to read because they would have to like scroll their screen sideways 2 feet. So I put the and at the end and I split it down and it lines up nicely and now we can read it very equally. So now it says if the choice is not equal to I and the choice is not equal to lowercase I, the choice is not equal to D and the choice is not equal to lowercase d, give the user a message and then stop. Does that make sense? All right, so let's see if that worked. Now, how many of y'all think it's going to work? How many of y'all think it won't work? How many are willing to give odds that it won't work? How many of you don't really know right now? I think it's going to work. Okay, 22.7, that worked. We can test it again, right? So that time I ran it, I put I in, 22 and 7 it ran. This time I'll put D in. Hey, look, 22 and 7, and that worked. So, have we improved our algorithm? Do we like this program better? Yes, we do. So, all right. Questions so far? Yes, sir.
Question a little bit unrelated to this, but back to the project actually.
Oh, project question. Okay.
Related to this area.
Sure.
So we're in the our algorithm, you have to put in, let's say they put a number outside of a range.
Uh-huh.
Do you have to give it a case they put a letter instead of a number?
No. You in the project, so the question was, If in the project we ask someone for a number and they give us a letter instead, do you have to handle that in your program? And the answer is no. Your program will either crash or will give you horribly incorrect answers in that result, but we're not going to take you off for that because I haven't taught you how to detect that and correct it yet. Yeah, you have to you assume that the people will, if you ask for a letter, they'll give you a letter. Assume if they ask for a number, they'll give you a correct number. Okay. It's much more complicated to handle the wrong type. We'll see how it works. But yes? Mm-hmm. Okay, so the question, which I am so glad you asked because it leads nicely into the next thing I'm going to show you is, here we had like a couple of choices, right? Say we had I or D. Let's say that we wanted to have our program also say like F for floating point, or W for whole number, which is whole number kind of like an integer? Let's just pretend that it is, and don't tell your math professors on me, right? Here we only had 2 choices, but let's say we had more choices than 2. Would that be really annoying to have to sit down and type I, D, 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 I, D, D, F, F, W, W, right? So on. How many of y'all think that would be annoying? Yes, and here's the secret. If there's something that's probably going to be annoying, programmers have probably thought of a better way to do it that is less annoying because they're lazy, right? Lazy in the good way, do as little work as possible for maximal effort, and so it's nice to be able to check things and see, right, without having to type all that out. So that is an excellent question. You're absolutely right, and that's what we're going to talk about next. Any other questions before we go on? Yes, sir. Yes. Okay. Strictly necessary, no. The computer will work perfectly fine without them. It is typical to use them because then it makes what you're actually doing clearer to other programmers. Okay? If we took all those out, would the computer work? I don't know. Probably, maybe. I'm not even going to test, but I just always write code this way and suggest you do too. All right, everybody happy? Let's take a 1-minute break, stretch, shake out, stand up if you need to, whatever you like. What? Yeah, I'll upload these programs this afternoon. Sorry. This whole program will be uploaded. In fact, I just made a new version of it so that as I make changes, you'll see the changes that I made over time. So, yeah, I just didn't get a chance to do it because I was screwing around with the videos, getting those to work. So, okay. Okay, so I just had a question which says, mine is in pretty colors that indicate what the value of thing is, and it actually helps because if you make a mistake, the colors will get off, and you'll spot it right away and go, there's a mistake. You are working on the Nano editor, which is, it's like the Tinker Toy editor, right? And it's no offense to you, it's just there's so much to learn at first that I wanted to give you a relatively easier editor to work on. Maybe in the world somewhere there's people who program a lot who use Nano editor. I would be surprised if that were the case. I just gave you that editor because I wanted to not kill you all with too much stuff. If you want to use another editor like Emacs, if you want to use a thing called an IDE, which is an integrated development environment, which I'm not using but can show you, you can use that and it will do all this pretty color. But you have to kind of learn that on your own. And There's so much to learn up front in this class that I keep trying to push all of it back as far as possible. Does that make sense? So you can have pretty colors too. You just have to change your editor. All right, give me 1 second because my I just realized my battery on my microphone's dying. So. All right, check. All right, that seems to be working. Okay, so welcome back. And what we were just talking about is this construct, if you have a lot of things that you want to check, gets really annoying to have to type out each case over and over and over again, doesn't it? So language designers and the people who write the C++ language have added this way of checking a lot of things at the same time, all at once, in one fast fell swoop, okay? And the way they do that is they use something that's called a case statement. I'm sorry, a switch statement, or a switch case statement, okay? So we're going to replace this long if statement with what's called a switch statement. And the switch statement allows you to check multiple things at the same time. And it also lets you check, if you're testing multiple things, whether or not any of the things you were looking for was found. So let me just describe how this works. What we have is you use this keyword, which is called switch, and then in parentheses, you have the thing that you want to test, or the things that you want to check on inside that parentheses. So what we're going to do is we're going to replace this long if statement with a switch statement. The thing that we're repeatedly checking inside this if statement is the value of the variable choice. So the thing that we're going to switch on is called choice. Let me recenter that a little so you can see. All right. So here's what's going to happen. We say we're going to switch on choice, and we're going to provide a list of valid values for choice. Okay? And we're going to be able to jump directly to what we want to do in that value based on what's there. So let me just give you an example. The easiest way to do it is to show you. So we say case I. We can say case lowercase I. We can say case D. We can say case lowercase d. And then we have this break, and I'll talk about break, and then we can have the thing called default, and default is essentially if it is none of these other things. If it's none of the stuff up above, do this. Yes? Thank you. So I often have a rule, sorry this one got a little mushed, if you catch me in an error I give you candy, so, which I give out a lot of candy for that because I also range from imperfect to worse than that. Let me just make sure I get this part right. Okay, so here we have this set up, and what will happen when you do this is the computer will bang along and it'll go, okay, choice. Let's say we typed in lowercase I. Okay? It'll go, okay, let me look through this list of things and see if any of them match the value that's in choice. Okay, so up here we enter lowercase I, and it says, okay, choice. It goes out to memory and it retrieves the value for choice, which is lowercase I. And now it looks through this list and it goes, okay, if it's I, is uppercase I the same as lowercase I? It is not. It says, is lowercase I the same as lowercase I? It is. So it will match right here. All right? There's a little bit of wacky stuff about this, but essentially what it will do is it'll then go down to the first thing underneath the list that is not one of these case statements, right? Because we're clumping all these together. And it just says break. And break means, in the case of a switch statement, you don't have to do anything. So it says, okay, I've matched one of these things in here. All I have to do is break, and I'm done. Does that make sense? But we also have this case which is default. And default says if you don't match any of these single cases, do this other thing down here. Everybody with me? So if you match one of these things in the list, you drop down to the first thing that is not on the list and do what it says to there. And what does it say to do? It says to break. And what does break do? It says we're done with this whole switch statement. Okay, we're just done with it. Otherwise, do the thing that's in default. So if we find uppercase I, lowercase d, or uppercase d, what do we have to do? Is there anything we want the computer to do in the event it finds one of those things? You're shaking your head no, right? You're correct. There's nothing we have to do in the case of one of these things because we're going to continue processing, right? We're going to go on and ask for input and do the division. You have a question? No. Okay, but what if it's not one of these four things? What do we want to do? We want to output what? How about we output the things that we had up here, right? We output these two lines. Well, we output this line, right? See out input must be an I or D, and then we stop. Is that what we want to do if the thing that is input doesn't match that list of choices? Yeah, it is. So I'm going to cut this, paste it down here. We'll say input must be an I or D, default 0. Okay. So now I'm also going to put this back up here just for posterity's sake. And what I'm going to do is I'm going to comment this area out. Okay. And so I just commented out that if statement. So when the compiler is running along and gets there, what's it going to do with this? It's going to ignore it, right? Even though everything in there is valid code, because we put those comment slashes at the front, it's going to ignore it. And we've replaced that if statement with this case statement, this switch statement. I don't know why I keep calling it case statement. With this switch statement. That should do, hopefully, the same thing. Do you have a question? Yep, this is a list. Each case is essentially a list of what you want to do. And what you want it to do is the statement after the list. And what we're doing is just breaking. And breaking means just get out of the switch statement. Yes, if we wanted to, we could put break after each statement. And we're going to play with this switch statement after we do this in just a few minutes. I'll show you some other stuff we can do. Yes, sir. Yep, this one matches there, right? If we wanted to, we could put stuff inside curly brackets in here. We don't have to in this situation. So, yes. Yes, both, assuming that I did not make some error here that I'm not seeing yet, which will turn up during compiling or testing, then hopefully we have replaced the functionality of that if statement exactly with this switch statement. Hopefully. See what happens when we compile it. Yes, sir? So we're going to do more with this switch statement as we go along. This is our first exposure to it. We'll get better switch statements as we go along. Okay? All right. Who's happy? Who thinks switch statements are going to be way better than typing giant long if-thens that are full of these horrible constant names that I'm making you do? You should be raising your hand very high for that one. Okay. All right. So let's just see if we screwed anything up. I'm going to save this program. Let me just take a quick look. Looks okay. All right. I've renamed this program from divide 2 to divide 3. Again, that's so I can put different versions of the programs up for you to go back and look at if you want to. Let's see. All right. So we compiled successfully, which is always a good thing. Let's see what happens when we run it. Do we want integer or floating point? D. Uppercase or lowercase? Okay, 22 and 7. All right, that worked. Let's try I. 22 and 7. Hey, that worked too. But we're going to be thorough and we're going to test all our choices. Uppercase D, and that worked. And we still, let's see, we did a lowercase d, lowercase I, uppercase D. Means we need a lowercase d, right? Uppercase I, up, thank you. 22 and 7. Okay, we're going to try that. So each one of these things that we did worked, right? One question that I hear people muttering about in the back of the room, which you can ask me out loud, which is, how the hell am I typing all of these things in one keystroke? I am an incredible typist. No, the answer is that I'm actually, when you're logged in to the computer, if you push the up button, it will take you back, and there's like a list of things you've typed before. So I can just do up and down. And for my particular computer, I have it set up so if I type H, it will show me the whole list of everything I've typed. Okay? Yeah, you might have to type history. For me, I've just told it to treat H as history. But this is just kind of a user interface thing. This is not part of the compiling. I'm just trying to give you this little hint. Most of the time, I just use the up arrow. And in my computer on my desk, I've got a window open that mine also keeps count of how many things you've typed. Like this 108 is a number. It's up to like 9,000 or something like that. And every now and then, I'm just like pushing the up arrow, and after like 100 times, I'm like, maybe I should look at the list. It'll be there eventually. But see, I do sometimes suck. That's on the suck end of things. Okay, so that's just a clue for you. I also have C set up to clear the screen, stuff like that. That makes it easier. Okay, so we're going to divide. We've checked uppercase I, lowercase I, uppercase D, lowercase d. What else do we have to check? Things that are not that. So you want to try X? Input must be an I or D. How about 0? Input must be an I or D. Shout out values. Let's see if it's working. Whoops. All right. So it seems to be working, right? We're just throwing things at it. The stuff we want to get through gets through, and the stuff that does not, does not. Are we happy? Yeah, let's give ourselves a round of applause. Great. So let's go back and take a look at our program now, okay? And I'm going to make the font a little bit smaller just so we can see what's going on. All right. First thing I'm going to do, just because we don't need it anymore, is I'm going to get rid of this comment about the if statement because it's gone, right? Sweet. Okay, so here's what we do. Let's look at our algorithm to see where we are. We declare some variables. We input a choice. We check if the choice is valid or not. If it is invalid, which means that it falls through to the default statement, we stop the program. Otherwise, we continue on. If we end up continuing on, we output, tell us what numbers you want to divide. We give the user a chance to input them. Everybody good with that? I kind of ran through that quickly. Nod if you think that's good. Yes?
I'm confused about constants. I don't understand.
Uh-huh.
I don't understand where you put them,
Okay.
what they're used for really.
We are not using any constants in this program right now. So it is a language feature that we will need for our program, but not for this one. Now, let's say that we wanted to later, let's say that we later wanted to see, if I could just type, that would be nice, wouldn't it? Let's say that later we just wanted to see if the thing that people divided happened to work out to be pi. We could add a constant that had pi there. That's actually a good point. I've given you the assignment to use constants without using them as an example. So thank you for pointing that out. But this is how they're defined. They're defined in the same place as a variable. They just have the word const in front of them.
But what does that do to your program?
It does nothing. Okay, so what does this do? Let's pretend that this const wasn't there. I can't actually shade it out because it projects on my hand. Let's say that const wasn't there. What does float pi do? So it says we're going to declare a variable. What is its name? What is its type? So it says go over to memory and save a little box for me. Name it pi. Tell it it's a float. And what value do we put in there? 3.1415, right? We can't put all of pi in there because it goes on infinitely and our box is too small to hold infinite things. Now the only difference between declaring a variable and declaring a constant is when we put const in front of here, it means that we can never ever change it again. Does that sort of make sense? So what, are you free this afternoon from like 1 to 2? Okay, send me an email and we'll find time and you can come by my office and I'm happy to explain it. Or you can stop by and see the TA, okay? You're absolutely welcome. I want you to understand everything. Okay, so here's what our algorithm is doing. Just to step back to that, right? These two lines say choose an integer output and then input. We check using this switch to see if the value that the user entered was something that we were expecting and made sense. Then we output, input the dividend and divisor separated by a space, and then they input it. We have a commented out debug statement here. And down here, we say, okay, now we're checking to see what the choice was. Now, haven't we already checked to see what the choice was? Didn't we already do that in the switch statement that was, up there somewhere? We did. We already checked. So, in a sense, we don't really need to check again, right? And in fact, this isn't too bad because there's just two choices here. But what if there were like 10 different things that we would accept for integer division, right? We would have to turn this into a really long list of stuff, even though we've already checked up above. Everybody kind of see where I'm getting at here, right? We've already checked once, and here we are checking again. Would it be better maybe if we only ever checked one time? Because now what happens, and I'll just tell you from a programming perspective, is say someone comes along and says, oh, it's nice that I also is valid, right? But let's make P also valid for integer numbers because that's what it is in Portuguese. I don't even know, right? In some other language, and you want to do So now you have to change your check in two places. You have to change it up at the top where you see if it's valid. You have to change it down here as well. And that gets really annoying, right? Programmers are lazy. We're lazy in a good way. Minimal amount of effort for maximum amount of results. Why check twice if you can only check once? Does that make sense? Do you understand where I'm coming from? Yeah.
Would it be useful to check that they inputted the right thing for the dividend and divisor?
We'll worry about that later. Okay. So we'll worry about that later. Okay. But everybody see where I'm coming from, right? We checked using the switch statement up above whether it was valid or not. And now we're checking down here again, and that's just annoying. So let's go back and look at our switch statement just for a second. So here's our switch statement, and the way this works is it says look up this value. Once you figure out what it is, compare it to the list of things, and then do what is the next statement that is not one of these case things underneath. Could we split this up right here to check for integer and decimal separately? We could, couldn't we? How many of y'all think we could check separately? How many of y'all think we could not check separately? How many of y'all aren't sure? Okay, so let me show you. Here, what we're trying to do is that when the user enters an uppercase or lowercase I, it's integer division. If they enter a lowercase or lowercase d, it is decimal. So even though I put all four of these cases together in one block, we can split them apart. And the way we split them apart is just by putting another break between them like that. Now, what this says is essentially check the choice. If it's an uppercase I or a lowercase I, break, you can just leave. If it's a lowercase d or an uppercase d, it's a break, you can just leave without doing anything. Or if it's none of those things, we output our error message and stop the program. Okay? So here's what we've just done. Here we've decided that if it's one of these two cases, it must be what kind of division? If it's one of these two cases, it must be. So let's keep track. Right now, we're not keeping any track of how we decided that. So let's keep track of whether or not we are doing integer or decimal point division. How can we keep track of the results right here? Yes, sir. Okay, so if we did an output, it would output something to the screen, but would it later on in the program, would the computer somehow remember what was output? How do we remember things if we want to remember things? And how do we store it? What symbol do we use? Equal sign. So the only way we're going to remember, I'm actually glad you all caught that because that's sometimes a weird concept. The only way that we're going to remember things is if we set something equal to something. So down here, let's set something equal to something. Let's call this one, let's create a variable called integer division. And what type of variable is this going to be? A bool? Why a bool? Boolean. It's either true or false. Does integer division have to have a number assigned to it? Does integer division have to have a letter assigned to it? A decimal number? So, if we're doing integer division, it's either going to be true or false. Everybody follow that? We are either doing integer division or we are not doing integer division. So let's just say if it's I, this is equal to true. And if it's not I, but it's D, let's make it to false. Set it to false. Yes?
So why is it only one equal sign?
Because it's assignment rather than comparison, right? We're not comparing integer division to true. What we're saying here, what this algorithm this is expressing says, check the value that's in choice. If it's an uppercase I or a lowercase I, we're going to remember that fact, one sec, by setting this variable integer division equal to true. Because the algorithm we're doing is if the user does uppercase I or lowercase I, we're going to be using integer division. If it is a D or a lowercase d, then we know it's not going to be integer division. It's going to be false. We only have two kinds of division right now, integer and decimal. So we can just set this to false. And now, since we checked the input, we're also going to remember what the result of that check was, which we will use lower down in the program. Question, yeah? Okay, I haven't defined this yet, right? I've just kind of thrown this in here, which is good. So let's see what happens if I try to compile it. What's going to happen, do y'all think? Okay, so what it says is in int main at line 28, integer division is not declared in this scope. And this happens to me all the time. I'll program along and I'll just make up a variable and then I'll go, oh, I forgot to declare it. So where do we go? We go up here and declare it. And we say bool. Integer division. If we want it, we should initialize it. What do we initialize it to? Most of the time it's customary to initialize things to false or 0. Yes? I did copy and paste. Yes. You can do it in Nano. You just, if you look at the Nano tutorial, it'll tell you how to cut and paste things. So, and I'll tell you, this is, like I said, this editor that I'm using is called Emacs. Emacs is incredibly powerful. It's so powerful that it has its own programming language that you can program inside Emacs to make it do things. Okay? It's nuts. Like I said, Nano is like, garden shears that you cut with your hand that are blunt so you don't hurt anybody, and this is the chainsaw with the snowmobile engine. These things actually exist. Anybody ever watch ESPN? They have lumberjack competitions to see who can cut through the log fastest, and they literally make giant chainsaws with a snowmobile engine because they're more powerful and they can cut through a log like this fast in like 2 seconds. Of course, if you're not careful, you can also cut yourself in half in like 2 seconds, which is why I'm not teaching you Emacs up at first. It's got a bad learning curve, but then it's very powerful. I am, in fact, an Emacs novice compared to a lot of people. So I use it. I've been using it for a really long time. I'm going to say since about 1993, 1991. A really long time, right? 1991, I think. And I'm a novice. It's incredible. So, okay. So that's an aside about the editor. Let's go back and say, so now I've declared this variable, right? And if I compile, it's happy now because the variable is there. But, so let's just take a look and see what we did. So here we declared this variable, right? Integer division. Here in this switch, we said we're remembering whether people entered an I or a D, right? And we're remembering that by setting integer division equal to true or false. Where do we use that? Where do we use that memory? Well, we use it down here because we were trying to remember if we were using integer division or not. So I'm going to replace this that's actually checking the value with this term integer division. And I'm going to get rid of this because, in fact, if it's true, we use that. And I'm going to get rid of this output because we no longer need it. Okay? Yes. Yep. Here, I'm going to put all that stuff back really fast, and I'll go through it again. Uh-huh. Yep. Yes. So, all right. So here's what I've done. So I'm splitting the screen in two so that we can look at two parts of the program at the same time. Okay? This gray bar indicates like the top part or the bottom part. Does that make sense? What's going on the screen? Okay. So up here I declared this bool interdivision equals false. I declare it false not because I need to declare it false there, but because it is good programming practice to initialize your variables so that you know what they are. Okay? As it turns out, in this case, if we didn't initialize it, it probably wouldn't be a problem because we are setting it explicitly below. But I'm just initializing it because... No, it doesn't. It's not a word. What type is this? And what values can a Boolean have? True or false. So what we're saying is this thing, we've created a variable. It's named integer division. This variable has a type, which is a bool, which means that we have a box in memory that can hold a value that's either true or false. And I'm saying in this case, false. Okay? It's nice. C++ lets us write out true or false. Sometimes you'll see people use 0 or 1, 0 being false and 1 being true. Yes? No. If you do not define what's in there, the state is not determined. You don't have no idea what it's going to be. It's customary when you're initializing your variables to initialize them to like as neutral a value as they can be, right? So for numbers, we typically initialize them to zeros. For letters, we might initialize them to a single space. For bools, you customarily initialize them to false. This is not always a good thing. I mean, but as a general defensive programming practice it is. Yes, sir.
Should we reassign it to false when we decide that it's floating division?
Yes. Yes, which is exactly what I did, right? So up here I just said it was false, and down here where I made the choice, I actually reset it to false again. Okay? Now, you might think, gosh, we made the computer do one extra step, right? How long did it take that computer to do that extra step? Seriously, how long did it take? In units of time, how long does it take the computer to do one step like that? Pardon? On the order of nanoseconds, perhaps fractions of nanoseconds. Okay? So here, by actually writing it in, we've made it clearer to us big, slow people, right? And we've added 1 billionth of a second, 1 billionth or 1 millionth or I don't even know, nano, one tiny, tiny time slice to the computer. So it's better to explicitly write your programs for people, not for the computer. Does it answer your question? Yes.
Can we use 0 or 1 instead of false or true?
I would prefer you use false or true, just because 0 and 1 is kind of more of a C style. You were going to develop your own style as you program anyway, and part of this is going to be looking at other students' code and seeing what their style looks like. So you're going to develop your own style. I'm just suggesting this is the way that I like to do it. And of course, since I like my style, I think it's best. And I like to read my own code, so you all should write code that I like to read, which looks just like mine. Yes? Okay. Yep. So let's take a look at this switch statement. I'll put it on the screen, and I'm going to blow up the font a little bit so we can see it a bit better, okay? Here's how the switch statement works. It says, enter here, get the value of the thing that's choice, and then start comparing to the list, okay? When you find a value on the list, go down underneath the end of the list, and then do what's there, okay? So it's going to do the inner division, and then it's going to break, and break drops it out of the switch statement. It's underneath this list. You can think of all the different cases as a list. The indenting is just the way my browser does it, my editor does it by default. Yeah, it says, okay, here, here, it's not one of those things, here, here. I mean, it just looks at these list items, and it skips over this stuff unless it matches one of the list items. Mm-hmm. Yep. Something for uppercase I and something for lowercase I and something for them together. Yes, there is, but I don't want to explain that now because it will... you can't do it twice because it'll stop the first time on the first one. That's like a Zen puzzle thing. I have to think about that. So, yes. That's way more, by the way, that's way more complicated than anything we need to do here. So, yes. Yep. So that's a good thing. So choice, when it's doing this, it only compares these things. There's no way to do like not equals. Or greater than or less than. Yeah, it's only for explicitly matching values. It's essentially equal, equal. Yes, sir. It simplifies otherwise very complex logic. So remember before, I took it out now, but we had like if it's equal to I, or if it's equal to uppercase I, or if it's equal to D, or it's equal to lowercase d. It makes it much easier to read. And trust me on this, this is actually a really small example. Like you might have a switch statement that has tens or hundreds or thousands of possibilities, okay? It gets really big. I can tell you when I wrote my master's thesis was essentially a giant switch statement. Actually, it was switches within switches, but each case was like huge. So, and there were like 50 choices in each switch statement. Yeah. So this works out really well because, well, other questions? All right, I'll just tell you how I used it. Here's what I did, okay? I had an if statement in my project. I'm not going to write the code up. I will just tell you, and I'll speak slowly so you can go back and find it and listen to it on the recording. Okay? Here's how I did mine. I had an if statement that said, if age is greater than or equal to 20, and if age is less than or equal to 24, age range equals 1. If age range is 25 to 29, age range equals 2. I had a variable named age range. Once I set these variables, I could then use them in a switch statement. So I could use, switch on age range and pull the value out of there. Yep, that's fine. So I used an if statement to figure out which age range I was in. I just checked that one time. I checked once to figure out which age range I was in. And then, as I went along, I could use the switch statement to never have to check age range again. I just... Yeah, I mean, I had, age range base, age range 1 min or something like that. So I did use the constants. Okay, we're probably going down the rabbit hole of complex stuff. So I'll listen to your question, but I'm going to reserve the right to not answer it. If you can think of some clever way to do it, sure. As long as it's right. So it's your algorithm. I'm not telling you that there's only one way to do this. There are a surprisingly large number of ways to solve the same problem. You're going to see each other's code, and you're actually going to see the code from the other section as well, and you are not going to find two people who did it really exactly the same way. So, and you'll see my solution too. Yes? No. Mm-mm. If your algorithm's correct, that's fine. Sure. If you have no switch statements in your program, that should be fine. I'm telling you, it's easier to do it with switch statements. No. No. Okay. And if you're frightened because she hasn't done she's programmed before. Again, remember, half the questions from people who just look around and see who keeps asking questions. There's like, from up here, I see 6 or 7 people. And they're always asking the questions because they've programmed before. Don't let that frighten the other 40 of you. Okay? All right. Okay, where were we? Okay, so here, now what we've done is we've checked to see whether we're using integer or decimal division at top. So if we go down in our program and we go down to the bottom now, what I've done is I've changed this to say, hey, look, if we're doing integer division, do integer division. Else, we don't even need this. We'll get rid of this. Else, do floating point division. And down here where we have this check to see if it was wrong, we don't even need that anymore because we did it before. So let me just test this and make sure we didn't completely screw something up. All right, what do we want here? Integer? That seemed to work. How about uppercase I? That seemed to work as well. So far our logic seems to be working, right? I compiled it. I'm running the program here by typing /divide. I give it either a lowercase I or an uppercase I and 22.7, and it gives me 3 remainder 1, which seems correct. We good so far? Now let's see if it works also for decimal. That seemed to work, right? For lowercase d. That seemed to work for an uppercase d. We happy so far? Everything seemed to be working? And then what happens if we give it an x? It tells us we're stupid. What happens if we give it a z? It tells us we're stupid. What happens if we give it a question mark? It tells us we're stupid, and so on and so on. How you all doing? How many of y'all are happy? How many of you are not very happy? Sorry. All right, so class is about over. What I'm going to do is I'm going to go back to my office. I will upload onto the documents portion of Blackboard the different versions of the program we've done. You feel free to download them, compile them, play with them yourself. Okay? And the video, I don't know, I'm learning to do the video stuff. It takes a while to get it posted to YouTube. It's slow. So have a good Wednesday.